Folks, we are on the Unit 3 Day 8 video. We're looking at how to solve linear systems using matrices. This is kind of just a skill that we're going to learn independently of our work with vectors and lines and planes, because it will help us in solving the more complex systems of equations that we're going to get to in the Day 9 and 10 lesson. So first off, what is a matrix? So not the movie. It's a rectangular array of numbers arranged in rows and columns. So there's lots and lots of different mathematical applications of matrices. We're going to be using them in a really limited sense, just to solve systems of linear equations when we have more than two variables, and they do really streamline the process of that. But they do have lots more applications in kind of higher math, and anybody going into math, engineering, computer science in university will likely see these a lot more in your future. So it's kind of nice to get at least a little bit of exposure to them in this course, so that you're a little bit familiar at least with at least one of their many applications. So the first question we're going to do is really basically a grade 10 question. We're going to solve an equation using elimination. So the first step in elimination, remember, is that we want to be able to get one of the variables to have the same coefficient for x and both x's or both y's. And I know that the y is probably easier here, but just to kind of make it as hard as we can, I'm going to get the x's the same. And here I'm going to multiply the first equation by 5 to give me 15x minus 5y equals 40. And I'll multiply the second equation by 3 to give me 15x plus 6y equals 18. And then we would subtract down in the columns to eliminate the x's. This again, just grade 10 solving systems. So we have 0 x's, which we don't normally write, but I will just to kind of show you the placeholder there. Sorry guys, I'm filming outside and there's a bug. Negative 5y minus 6y is negative 11y. And then 40 minus 18 is 22. And then I'm going to divide this whole equation. So I'm writing this a little bit differently than you probably would have seen. But I'm going to divide by negative 11, the whole equation there. And then I get 0x plus y, 1y equals 2. So that gives me a solution of y equals 2. Right? Normally we would take that y value, sub it back into the original equation and find x. But we could actually find x using elimination again. We don't typically, because it is longer, but if elimination was really our skill that we knew, we could absolutely solve for the x by eliminating the y variables. So if I had 3x minus y equals 8, just copying down my original equations, I could do this. I could multiply the first one by 2, and I would keep the second one the same. And here I would be given 6x minus 2y equals 16, and the second equation not changing, with 5x plus 2y equals 6. And then I could add down in the columns here. So I would get 11, oh, this is a bit of an anomaly, 11x plus 0y equals 22, and then dividing both sides by 2. Oh, oops, I missed a negative up here. Just kind of going back, I had negative 11y, and divided by negative 11, that should be negative 2 there for my y value. Didn't think they were the same. So then dividing out here, I get 1x plus 0y equals 2, or just x equals 2. So that's how we would solve using elimination to solve for x and y in two variables. So I know you guys know how to do that, but let's kind of analyze what rules we're allowed to use, what things we're allowed to do in elimination, and we're going to generalize that to working with matrices to solve higher order equations. So we know with elimination we can multiply or divide an equation by a constant, and we can add or subtract equations or multiples of equations. So that's really all we did there, right? We multiplied equations to get common coefficients, then we added or subtracted those equations, and then we multiplied or divided equations again to get a coefficient of 1 where we had a solution for either variable. And that's what we're going to do with matrices. So we're going to write equations as one row in a matrix. And if we do that, we're allowed to do all of these same things because the equations go into a row. So we can do things to the row that we can do to any other equations. So for instance, we can multiply or divide a row by a scalar. We can add or subtract multiple rows or multiples of those rows, and we can swap any two rows because the order of our different equations doesn't actually matter. What our goal is going to be is to be able to get what's called the identity matrix on the left. If we have the identity matrix, this would represent 0 or 1x plus 0y equals something, and that's what we had in that solution by elimination, and 0x plus 1y equals something. In 3 variables, we would have 1x plus 0y plus 0z equals something, and that's really a solution for x, or 0x plus 1y plus 0z equals a number. So that's kind of where we're going to go with this. We're going to solve that same exact equation or system of equations, but this time using matrices. Now, just take a note of up here, it says it is not easier than elimination. It absolutely isn't. Nobody would actually use matrices to solve a 2 by 2 equation. That means 2 variables and 2 equations. But if you had 3 variables and 3 equations, matrices starts to get a lot easier. If you had 4 or 5 variables and 4 or 5 equations, matrices is probably the only way most people would be able to realistically be able to get something to work out for them that way. It's quite a lot more to keep track of as you get into more complex equations and a lot more variables to manage. So when we want to solve this with matrix operations, what I'm going to do is write each row into a matrix. So I'm going to create a matrix like that, and my first row, we're only writing coefficients. So it's 3x minus 1y equals 8, and I'm going to draw a vertical line there to represent where the equal signs would be. And then my second row is 5x plus 2y equals 6. Okay. The first step in solving for a matrix is to get the top left corner equal to a 1. And we're going to do that by multiplying or dividing by a scalar number. So we're going to divide the whole first row by 3. And it will get a little messy here. It doesn't always, and there's kind of ways to avoid it, but I don't want you to be afraid of fractions. So I'm going to write what I'm doing. Row 1 divided by 3. So I'm dividing the first row by that scalar. And this is how we kind of show matrix operations. You use an arrow and then you just write above or below the arrow what you did. So I would have this as 1, negative 1/3, and then 8 over 3, and still 5 to 6. You can do multiple steps all at once, absolutely, but for now I'm just gonna go nice and slow, one step at a time. The next step is to get zeros in the rest of the column. So I want to eliminate that 5. So I want to get a 0 there, and I can't multiply or divide. If I multiply or divide by 0, or multiply by 0 to get that 0, that I lose all my information about that row. So that's a bad plan. I want to add and subtract a different row or a different equation. So I'm going to take this row, so row 2, and I'll make it equal to its original self, row 2, minus, I would have to subtract 5 times row 1. So that means I'm creating a new row 2 by taking the old numbers and minus 5 times row 1, because I can add or subtract any scalar multiple of another row. So here, row 1's not changing, 1, negative 1/3, and then 8/3. Now here I have 5 minus 5 times 1, which will give me the 0 that I wanted. Now 2 minus 5 times 1/3. Again, this is going to get a little bit messy and it's going to look kind of bad, but so 2 minus 5 times 1/3. If you need to, write this out off to the side, because it is a little bit tricky to kind of keep track of fractions and negatives. Use your calculator if you want. So that's like 6/3 plus here plus 5/3, so we would have 11/3 in there. Just being really super careful to either do this on your calculator or write it off to the side if you've got kind of integers and fractions and you're worried that you might make a little mistake. Then I'm going to have 6 minus 5 times 8/3. So 6 is 18/3 minus 40/3. So that's negative 22/3. Okay. The next step, and I do have a good visual of this, so don't worry about writing down the steps. The next step is that I want to get a 0, or a 1, pardon me, in this spot. So I wanted to get this one first, then zeros, or this one and then both zeros. And then we get the 1 in the next column and then the zeros. So I want to get this as a 1 down here. And to do that, I have it as 11/3. I'm going to take row 2 divided by 11/3. So row 2 equals row 2 divided by 11/3. So I know I'm going to have that as 0, 1, and negative 2. When I divide out 11/3, I get a 1 and a negative 2, and the 0 won't change. Okay. Now, I may actually show this in all kind of independent steps. I'm not going to try and, normally I would do more than one step at a time, but just to make it really clear what's happening here. The last thing is to get a 0 up here. So I'm going to take this plus 1/3 of row 2, because I want to add a third to zero out that top right. So I'll say row 1 equals row 1 plus 1/3 of row 2. And notice that once we've got this 0, it's not going to affect the 1 up here. I can add any amount of row 2 and it won't mess up the 1 that I already have in the top left. So this order is kind of important, otherwise you may end up kind of going a little bit backwards. So I know row 2 is not going to change. Here I've got row 1 plus 1/3 of row 2. So I've got a 1 up here plus 1/3 of 0, which is still 1. I have negative 1/3 plus 1/3 of 1, which is 0. And now I have 8/3, which this is the part you may want to write out or do on a calculator, 8/3 plus 1/3 of -2. So that's kind of the thinking in your head or on a calculator or on scrap paper or somewhere. I get 8/3 minus 2/3, which is 6/3, which is 2. So this is really important because it does get a little bit messy sometimes with negatives and fractions, and you just have to be really careful because one mistake part way can really mess up the rest of your solution. So here we've got new equations. 1x plus 0y equals 2 and 0x plus 1y equals -2. So from here we've got our solution. We've got x equals 2, y equals -2. And again, I would never ever use this. I use this once a year when I teach this lesson to do elimination with two variables. It's not faster, it's not easier than regular substitution or elimination, but it will be if you get into 3 or 4 variables. So we're just kind of doing it with one variable first to practice.